So in this part of the tutorial, I just want to show you a few more examples of different things that can happen. So let's get started doing the same thing as we have been doing. Find the LCD first. In order for this, we need all denominators to be fully factored. 9x squared minus 4 is not. 9x squared minus 4 is our difference of perfect squares. Always look out for that one. So this is the same as 3x minus 2 times 3x plus 2. So our LCD needs to have a 3x minus 2, and then these two are taken care of. And it also needs to have a 3x plus 2. And these two are taken care of. Let's look at our domain restrictions. X such that x is not equal to. Remember our shortcut to get the number from our factor. Take the number, switch the sign, and divide by the coefficient of x. Positive 2/3, and take the number, switch the sign, divide by the coefficient of x. Negative 2/3. Those are our two domain restrictions. Now we're going to multiply each of the three terms by our least common denominator. I'm going to rewrite this. Here we go. Let's simplify. 3x minus 2 can be simplified. 9x squared minus 4 against both these factors. And 3x plus 2 against this one. Rewrite what we have. 3x plus 2 times 2x minus 1 plus 6 minus 2x is equal to 2x plus 1 times 3x minus 2. Foiling 3x plus 2 and 2x minus 1, I get 6x squared minus 3x plus 4x minus 2 plus 6 minus 2x. And foiling on the right, I get 6x squared minus x minus 2. Now let's combine like terms here on the left, and we get 6x squared minus x plus 4 is equal to 6x squared minus x minus 2. And again, we are trying to solve a quadratic equation by setting one side equal to 0. That means I'm moving all these terms on the right to the left. Minus 6x squared, there are no more x squared, plus x, no more x's, plus 2, I get 6. 6 is equal to 0. Wait a minute. 6 is of course not equal to 0. And what that means is we have no solution. See, that is a different way that no solution can come up. Similarly to what we had in Algebra 1, 6 is not equal to 0. This is false, and therefore we have no solution. On to the next one. Let's look for LCD. X has a denominator of 1. Just for completeness sake, no 1 we don't have to worry about in our LCD, since we're multiplying by 1, we don't change anything. So the only part of the LCD that matters is x minus 1, which we have twice, and so this is all taken care of. Next, let's look for our domain restrictions. X cannot be equal to positive 1. And now, again, multiply each of the three terms by our least common denominator. Here it is. Now in our first term, nothing to simplify since the denominator was simply 1. In the second term, we can simplify the x minus 1, and so we can, on the right side of our equal sign, which leaves us with x minus 1 times x plus 2x is equal to 3 minus x. Distribute, we get x squared minus x plus 2x is equal to 3 minus x. Combine like terms, we get x squared plus x is equal to 3 minus x. Now I'm moving everything to the left one more time to get x squared plus 2x minus 3 is equal to 0. And this we can factor x minus 1 times x plus 3 is equal to 0. So our solutions are supposed to be x is equal to positive 1 or negative 3. Let's check with our domain restrictions. X cannot be positive 1, so this solution doesn't work out. The only workable solution is x is equal to negative 3. So for our next example, before we even start looking for our LCD, there's a little trick we can use to make work easier. So I want you to mark this problem and remember how we do this. So if you look at your two denominators, 1 minus x and x minus 1, we see that they're nothing else than just flipped. So instead of using these two factors as two separate factors for our LCD, we can go ahead and take our term on the right side of the equation, just multiply it simply by negative 1 over negative 1. Because what's going to happen then? We're going to have negative 1 over negative 1 plus x, or in other words, x minus 1. And that shows us that we just need x minus 1 for our LCD. And our domain restriction is x such that x is not equal to 1. And that's all it is. Multiply both sides by our LCD. Here we are, and simplify. X minus 1 goes away here. Can't go away here, but it goes away here again. So we have negative 1 is equal to, and 1 times the parentheses, we don't even have to keep them, x minus 1 minus x. And we can simplify our right side. We get negative 1 is equal to negative 1 as the two x's cancel each other out. Is this a true statement or a false statement? This is of course true. And therefore that means we have infinitely many solutions. That is our other special case next to no solutions. Infinitely many solutions. If a final statement is a true statement, that's always true. And we move on to our next example. Looking for our LCD first. Is this denominator on the left fully factored? X squared plus 1 is actually the sum of perfect squares, which can't be factored any further. So this has to go into our LCD, and so does the 5. And this is our LCD. And what does that give us for domain restrictions? X squared plus 1 is not allowed to be 0. Can it ever be 0? Can a number that we plug in for x that's squared ever be negative 1? Not in the real number system. In other words, we have no restrictions here. Yay, that's the first, right? No restrictions. Now let's multiply everything by our LCD. Ta-da! And what can we simplify? X squared plus 1 can be simplified here on the left, and on the right, the 5 can be simplified. I'm going to write everything I have, and I'm already going to go ahead and distribute. So we get 5x plus 5 on the left, and on the right, we get 3x squared plus 3. And again, we have a quadratic equation, so let's move everything to the right this time. We get 0 is equal to 3x squared minus 5x minus 2. Can we factor this? Well, let's check it out. But let's not forget that our target sum is negative 5, but our target product is actually the product of 3 and negative 2. In other words, negative 6. And which two numbers give us that target sum and that target product? The answer is the numbers are negative 6 and 1. Now, since our lead coefficient is not 1, we need to split our middle term. So we have 3x squared minus 6x plus 1x minus 2. And let's now factor them in groups. 0 is equal to 3x times x minus 2 plus 1 times x minus 2. And fully factored, this is what this looks like. 3x plus 1 times x minus 2. So in other words, our solutions are x is equal to, take the number, change the sign, divide by the coefficient of x, and positive 2. Take the number, switch the sign, divide by 1. Same thing. Those are our two solutions. Let's look at our restrictions. There were no domain restrictions. In other words, both of these numbers are solutions. Excellent. And let's move on to our last example. LCD. The LCD is going to be x and x minus 4. That's our LCD. Do we have domain restrictions? This time we most certainly do. X cannot be equal to 0. X can also not be equal to positive 4. And again, we're multiplying everything by our LCD. Here we go. Now let's simplify what we can. X against x. For our second term, we can't simplify anything, but x minus 4 against x minus 4 on the right. And rewrite what we have. X minus 4 times 10 plus 3x times x minus 4 is equal to x plus 9 times x. And next I'm going to distribute 10x minus 40 plus 3x squared minus 12x is equal to x squared plus 9x. Combining like terms, we get 3x squared minus 2x minus 40 is equal to x squared plus 9x. Now I'm going to again move everything to the left, subtracting x squared, 2x squared, and subtracting 9x leaves us with 11x minus 40 is equal to 0. So, are there any numbers that we can use for factoring? Our target sum is negative 11 as always, but our target product is again 2 times negative 40, which is negative 80. So which two numbers will give us negative 11 and negative 80? And the answer is negative 16 and positive 5. Let's split our middle term then. 2x squared minus 16x plus 5x minus 40 is equal to 0. Factoring in groups, 2x times x minus 8 plus 5 times x minus 8 is equal to 0, or 2x plus 5 times x minus 8 is equal to 0. And here we have our two solutions now. X can either be negative 5 halves, or it can be positive 8. One look back at our domain restrictions. We had 0 and 4 as our domain restrictions. Our solutions are neither of these two numbers, so both these solutions work perfectly fine. And that's it for today. I know this was a little bit of a longer tutorial here. Sorry about that, but I wanted to make sure that you get to see a number of different examples. So, good job you guys, and I will see you in class.